Welcome my viewers to my YouTube channel, CAOCHEMISTRY. When you're taking an undergraduate course in Bachelor of Science Chemistry and Organic Chemistry, feel free to follow my tutorials because you're going to really learn a lot. So last time we were discussing about the aldol reaction mechanism, and we were forming an aldol, which is basically here. And we discussed on how the mechanism for that particular reaction works. And so I promise you that in the next video channel I will be uploading something to do with now the Retro-Aldol mechanism. And so this is our aldol product, which is basically coming from aldehyde. Remember the name of our aldehyde? Yeah. What was the name of our aldehyde? Yeah, it was acetaldehyde. And so we were adding now OH and H2, and we were able to form our aldol product here. And so, viewers, today we want to perform now a retro-aldol process. Remember, I said that an aldol process is actually a reversible process. A reversible process is that process, of course, which can go forward and which can go backward, and we normally denote that with these particular arrows. Any reaction that has this particular arrow, we call that reaction is called a reversible reaction. And so, before we start, there are two fundamental points you're supposed to take note of. We have these two positions in the aldol product. We call this position alpha and beta position. These, of course, are Greek letters. Should not worry you. This is just an alpha and this is just a beta position of this particular aldol. So it's called alpha beta hydroxy aldehyde. In general, we can call this structure alpha beta hydroxy aldehyde. And so we want to generate our acetaldehyde from this particular product. And first of all, let's start by drawing this particular structure here. So we are drawing that particular structure, our aldol. Of course, this is our beta position. Okay. So, viewers, there's something I want us to take note of. We have an OH group here. Of course, there's a bond between oxygen and hydrogen. And the first synthetic way to go back to our acetaldehyde is by introducing by grabbing this hydrogen here. We have to see a way this hydrogen is going to be grabbed, and of course we have to have our base, which basically we were using sodium hydroxide. Or the base is coming to grab this particular hydrogen here, and of course whatever thing happens here is that we are going to generate some lone pair of electrons here, and this oxygen is going to be negatively charged because the hydrogen has now been eliminated from that particular structure. So overall we get something like this. Of course, this is our alpha position, this is our beta position. The oxygen here now has this particular lone pairs. 1, 2, 3, 4, 5, 6. There we go. That is it. The first process, the hydroxide ion has actually grabbed the hydrogen, and so we've formulated this particular ion, whereby something is going to happen from here. There is going to be a formation of a bond, a double bond here, because this lone pair of electron is coming to form a bond here, a double bond, of course. Now, there's something that happens here. Of course, the presence of the pi bond here somehow causes some discomfort, this alpha and the beta, the alpha and the beta groups here. Whatever thing happens here, remember there's some electrons. Anyway, let me wind up drawing the structure so that we don't bring a sort of confusion. There was a hydrogen here, or there's a hydrogen here. Whatever thing happens is that the bond between the alpha and the beta groups here uh, is going to be broken. Actually, there's some electrons that are being shared between the two, and that's what's actually forming this particular bond. Now, the presence of the pi bond here. Remember, the lone pair of electron is coming to generate a pi bond here. Let me actually illustrate it here. This is it. So there is a generation of a double bond here. There's been a generation of a double bond here. But anyway, I want to have a clear glimpse. I want you to have a clear glimpse of what's happening here. Of course, it has generated this double bond with the lone pair of electron, leaving out the two pairs of the two pairs lone of electron. And so the presence of this pi bond disrupts the states of this alpha and beta the alpha and beta groups. So whatever happens, the bond that is in between these two things, these two groups actually breaks. And so if it breaks, there's something that happens. This this compound actually, this structure somehow separates. It separates because the bond is now breaking, and it fundamentally breaks at this alpha bond, at this alpha group. Let me finish drawing the structure. It breaks at this particular point. Then what happens now? We are generating this particular product. Generating this particular product. So first of all, we have our enolate ion here. Of course, breaking at this point simply means that we are going to generate an enolate ion here at the alpha. So this enolate ion, and of course we have our O here, and of course this is it. Okay, this is it. Plus, now we have this other part of the structure, which is actually our aldehyde. Our aldehyde. Our aldehyde, which is having hydrogen here, and of course, this one is oxygen. So this is our complete structure of the aldehyde. Now, there's something that again coming to happen here, because we basically have this enolate ion, and of course, uh, when we in the presence of water, what happens? It is coming to the lone pair of electron comes to grab the hydrogen and generates the hydroxide ions, minus OH. And so whatever thing happens now, that the lone pair of electron here attacks the hydrogen and generates hydroxide ions. So the hydrogen is coming to attach itself in this structure. And so overall we are getting, okay, let me just represent it here. This one is now, we are getting this particular aldehyde. Let me just show it here. The aldehyde now remains to be this. The hydrogen is here, and of course we have oxygen here. Plus, of course, we have oxygen here, and we have hydrogen here. Yeah, there we go. We've shown how we can go back to our reactant, which were the two aldehydes. It's the reaction between the two aldehydes that were now able to give us the, the, the aldol product that we had here initially. And so that's the reaction mechanism for the retro-aldol process. Next time we meet, we are going to discuss about more on aldol condensation reaction, and therefore we are going to introduce, we are going to react, we are going to now involve the use of a base and a heat in our aldol reaction, and we are going to see whatever is going to be to happen to this particular structure when we introduce a base and heat So that one is called aldol condensation reaction. And that is what we're going to basically do in our next class. Keep chemistry, keep subscribing, keep following CAOCHEMISTRY channel. Next time we meet, have a nice